Hello. So this is lesson 6.2, and we're going to be talking about inconsistent and dependent systems and their applications. So let's look at what an inconsistent and dependent system is. We talked about those already, but in the case of systems with, so the ones that are inconsistent, that was the ones with no solution, or dependent, that was infinitely many solutions. So inconsistent is no solution, and um, dependent is infinitely many solutions. So what we can do when we have an inconsistent or dependent um, system, we can use the Gaussian elimination on systems with three or more variables to determine how many solutions such systems may have. So in the case with no solution and infinitely many solution, it is impossible to write the augmented matrix in the desired form. And remember, the augmented matrix in the desired form was the one where we have ones on the diagonal and then zeros under the ones. So again, it is impossible. So let's look at our system of equations here. We've got three equations and we're going to use the Gaussian elimination. So we're going to first write the augmented matrix just like we've done before. So 1, -2, -1, and -5 in the augmented column. 2, -3, -1, 0. 3, -4, -1, and 1. There's our matrix. Now, um, we're going to try to get the ones down the main diagonal and zeros below the ones. So the first thing we're going to do, we already have a 1 over here as the first one. So our next step is to change this 2 to a 0. So remember when we are trying to get to a 0, we are always adding. So what we're going to be doing is we're adding to row 2. Now we're going to use row 1 and we need the opposite from the for the 2 from the 1. So we're going to multiply row 1 by -2. So our first row does not change. And our third row does not change. It's the second row that changes. So -2 times 1 is -2 plus 2 is going to be a 0. -2 times -2 is 4 plus -3 is going to be 1. -1 times -2 is a 2 plus -1 is a 1. And then -2 times -5 is a 10 plus a 0 is going to be 10. Okay, so what did we achieve here? We already had that 1. We got a 0 under, and now we have a 1 over here as well. Well, we're supposed to actually try to get this to a 0 first. So again, we're trying to get it to a 0, so that means that we'll be adding to row 3, and nothing changes in rows 1 and 2. They're going to be the exact same rows. Now, we need to look at, we have a 1 here, and we need the 3 to become a 0. So we're going to multiply row 1 by -3, because -3 times 1 is a negative 3 plus 3 is going to be a 0. Next, it's negative 3 times negative 2, which is a 6, plus negative 4 is going to be 2. Um, negative 3 times negative 1 is a 3, minus 1 is going to be 2. Negative 3 times negative 5 is 15, plus 1 is 16. So that's our row 3 now. Okay, so what do we have here? We have a 1, we have a 0, we have a 1, and we have a 0. Now we need this 2 to become a 0. So we're adding to row 3 again. And now you've got to be careful when you are adding to row 3. We cannot use row 1 because if we add anything, anything in row 1, this 0 is going to change. So we're going to have to use row 2 in this case. And we need an opposite, so we need to multiply row 2 by negative 2. Okay, so our row 1 does not change, and our row 2 does not change. It's the row 3 that we are adding to. So negative 2 times 0 plus 0 is going to be a 0. Negative 2 times 1 is negative 2 plus 2 is a 0. Negative 2 times 1 plus a 2 is going to be a 0 again. And then negative 2 times 10 is negative 20, plus 16 is going to be negative 4. Okay, so what happened here? We have the 2 ones and we've got zeros under it. But now the problem is that we have a 0 right here. So what happens here if we write that third line, 4x plus 4y plus 4, 0 equals negative 4. This is going to be 0 equals negative 4. Well, that is false. So when we get a false like this, we know that it is a no solution. Or we can say that it is an empty set. Again, remember that empty set is either a 0 with a line over it, or if we write it in a set form, it does not have anything in it. So this one was inconsistent. Okay, next example is a system with infinite number of solutions. So we are again going to write our system as augmented matrix here. One, negative 3, 4, and 1. Here we go. Now, we already have a 1 here, so we want the 2 to become a 0. So we are adding to row 2. We're going to multiply by the opposite of negative 2 because we have a 1 here. So row 1, negative 2 times row, hold on a second. Actually, I'm sorry. What we're going to do instead of row 1, we're going to use row 3. And here's the thing. We could use either one, but you'll see why we're doing row 3 instead of row 1. So our first row does not change. It stays the same. Our third row does not change. It's the second row that changes. So negative 2 times 1 is a negative 2 plus 2. We get a 0 that we wanted. Negative 2 times negative 3 is a positive 6 minus 5. That gives us a 1. So this is why we actually used row 3 and not row 1 because we get the 1 from here. So there are a couple of options on how to do, how to solve these things. Okay, so what are we? Where are we? Negative 2 times 4 is negative 8 plus 3 is negative 5. And then negative 2 times 1 is negative 2 plus 6 is a 4. Okay, our next goal is to get the first column, third row element to become a 0. So again, we need a 0, so we're adding to row 3. So we need to use row 1 now to add to row 3 so that we're using the negative. So negative 1 plus 1 is going to be a 0. So our row 1 does not change. Our row 2 does not change. It's the row 3 that changes. So negative 1 times 1 plus 1 is a 0. Negative negative 2, so positive 2 minus 3 is a negative 1. Negative 1, negative negative 1, so two negatives make it positive, so it's a plus 1. Plus 4 is a 5. And then negative 5 plus 1 is a negative 4. Okay, we have a 1, 0, 0, and we have a 1. We need this to become a 0. So again, it needs to become a 0. Row 3. Well, our row 2 is the opposite, so we're just going to add row 2 to the row 3. 1, negative 2, negative 1, 5, that does not change. Neither does the second row. There we go. So row 2, 0 plus 0 is a 0. 1 plus negative 1 is a 0. Negative 5 plus 5 is a 0. And 4 plus negative 4 is 0. Okay. So we have our 1s and we have our 0s below our 1s, but we have a 0 here. Now, if we do 0x plus 0y plus 0z equals 0, we get 0 equals 0. So we know that this is true. So we have infinite number of solutions here. Now, when we have infinite number of solutions, what we can actually do is we're going to go ahead and take the first row and the second row here and leave the third row because it gives us zeros, and rewrite these two. 0, 1, negative 5, and 4. This is our augmented matrix without the third one. Now, what I'm going to do is I'm going to write these back into linear equations. So x minus 2y minus z equals 5, and y minus 5z equals 4. These are our two systems of equations now. Now, what we're going to do next is we're going to solve this for y. So we move the 5z to the other side, so we get y equals 5z plus 4. We're going to go ahead and plug this here into the y over here. So we have x minus 2 times 5z plus 4 inside parentheses minus z equals 5. Okay, we're distributing here. X minus 10z minus 8 minus z equals 5. We're combining like terms. So negative 11z minus 8 equals 5. Adding the 8, x minus 11z equals 13. And now solving for x, we get 11z plus 13. Okay, so now we have x equals 11z plus 13. we have y in z, 5z plus 4, and our z is going to be z because it, again, we have an infinite number of solutions, so z can be anything. So this is our solution set for infinite number of solutions. We can write it with one variable here. Like this, and that's an order triple, and it's a set, so we write it inside the braces. So what we just did here, because we had infinite number of solutions, we wrote the order triple as z. So every single one of these has z, and it has to be the same. It can be x or y, but all three have to have the same variable, only one variable in there. Okay, let's look at a system with fewer equations than variables. We're going to write this as an augmented matrix, 1, 2, 3, 70, 1, 1, 1, 60. There we go. And now we're attempting the same thing. Well, we already have a 1 here. So what we want to do is get this 1 to become a 0. So we are adding to row 2. We're going to add. We need a negative 1, so we're going to do a negative row 1. Row 1 does not change again. We're doing the addition to row 2. So negative 1 plus 1 is a 0. Negative 2 plus 1 is negative 1. Negative 3 plus 1 is negative 2. And negative 70 plus 60 is negative 10. Okay, we have a 1 and a 0. Now we need this to become a 1. So what we're going to do is we're going to just multiply row 2 by negative 1. Our first row does not change, so we're just switching signs here in row 2. Well, 0 doesn't have a sign. Negative 1 multiplying by negative 1 is a 1. Negative 2 multiplied by negative 1 is a 2, and then switching the sign on 10. Now we've got 1, 0, and 1. Well, we can't really go any farther because we don't have another. We only have two equations here. So what we're going to do now is write them as the linear equations that we got. X plus 2y plus 3z equals 70. And we've got y plus 2z equals 10. And again, from these two, what we're going to do is we're going to go ahead and solve y, or solve the second equation with y. So we're moving the 2z to the other side. We get negative 2z plus 10. We are plugging this in to where we have our y. So we get x plus 2 times negative 2z plus 10 plus 3z equals 70. Distributing and combining like terms. And yeah, now we're combining like terms. So we get x minus z plus 20 equals 70. We move the 20 to the other side. What am I writing? X minus z equals 50. And then we'll move the z to the other side. So x equals z plus 50. Okay, so there's our x. We have our y, and z is again going to be z. So our x is going to be z plus 50. Our y is going to be negative 2z plus 10. And we can't solve for z because we only have two equations from the beginning. So If we have three variables, we can only solve it for two of them, and that's what we just did over here. Okay, let me know if you have any questions. That was it for 6.2. Bye.